In this video, I'm going to go through another example of a multi-step conversion problem using dimensional analysis. We have the problem written up here, and I encourage you to pause this video and try this on your own first. Set up a strategy using units, and then plug that all into your calculator and try reporting the correct sig figs. All right, hopefully you've had a chance to do that. I'll walk through this solution. So if I have 1.27 times 10 to the negative 2 kilograms of liquid ammonium, it has a density of 0.769 grams per milliliter. What volume will it occupy in milliliters? So right away, I know my starting point here is this mass of liquid ammonium. And what I want is to get that into units of microliters. What's that volume that it will occupy? And I'm given a conversion unit right here that's grams per milliliter. So I'm going to start by writing this out. I've got 1.27 times 10 to the negative 2 kilograms. I'm going to note that I have 3 significant figures here and 2 decimal places. We're going to assume that this is an inexact number, that this was a measured volume or measured mass of liquid ammonium. All right, so I know I need to convert this using one or more conversion factors to get to a value that has units of microliters in the end. So immediately I'm going to say, well, let's just assume we've got 2 at least. I've got kilograms on the bottom of my first conversion factor because I do not want kilograms in my answer. And I'll end up with microliters on the top of my conversion factor. So I end up with microliters. And looking at this, now I can start to see that as much as I would like this to be a 2-step problem, I don't have a conversion factor that goes between microliters and kilograms at all. Instead, what I have is grams to milliliters. So I don't have grams and I don't have milliliters in my problem yet. However, I can quickly recognize that grams and kilograms are both mass units, and microliters and milliliters are both volume units. And so I can convert between them using the metric system easily. So if I convert into grams from kilograms and milliliters from microliters, then I can actually use this conversion factor that's been given to me, which would be grams. And I'm going to put that on the bottom because I want it to cancel out with the grams that my kilograms were converted into, and milliliters. So let's take a look at this based on units. If I were to multiply this all out, I would have kilograms times grams times milliliters times microliters on the top of my fraction. And on the bottom, I would have kilograms times grams times milliliters. And so looking at what cancels there, my kilograms would cancel, the grams would cancel, the milliliters would cancel, not the microliters. So this seems like a solid strategy. I'm going to run with it. So now after I have my units lined out, I'm going to go ahead and add in the numbers. So I know that for every 1 kilogram, I have 1,000 grams. Now I could also write this a little bit differently. I could instead write 0.001 kilogram equals 1 gram. I'll get the same answer either way. I've been told that my density is 0.769 grams. So that 0.769 is attached to that gram unit because it's the first one that follows it. So I'll put my 0.769 on the bottom of my conversion, and I'll put a 1 with my milliliters. Since it's per milliliter, it's an abbreviation of per 1 milliliter. Now going between microliters and milliliters. Now this one, it might be trickier to do without going through an intermediary. I know that 1 liter equals 1,000 milliliters, and that 1 liter equals 100,000 microliters. So I could just use this piece of that conversion right there, relating both of these to the base unit through their prefix. I could also divide both sides by 1,000 and come up with the conversion factor that 1 milliliter equals 1,000 microliters. So I'll use that one. So my 1 milliliter will equal 1,000 microliters. Be careful, microliters and milliliters can look really similar depending on the handwriting. The micro is really using a mu symbol, and milliliter is using an M symbol. All right, so now I've got this lined out. I'm just going to plug it into my calculator. And when I do, I get a value of 16514.95 microliters. That's a lot of significant figures. Now, remember, I only really get to have 3 of those. Everything's been multiplication or division, so I'm going to report the significant figures in my answer that I had to start with. All of my conversion factors are exact numbers, so they have infinite significant figures. So if I need 3, I'm going to go 1, 2, 3. So I can write this in a couple ways. I can write this as 16500 microliters using zeros as placeholders, or I could use scientific notation, 1.65 times 10 to the 4th microliters. And both of these answers would be acceptable.